All right. I need to start a little bit earlier for stream because every once in a while my computer needs to reboot to be able to get everything going. And that takes a couple minutes. How are y'all doing today? All right, let's see. We've got, this is part 2, right? No, this is process line. We can get rid of process line completely. And this is process part 2, which we will leave for the moment. And then let's take a look at the question before we start deleting everything. Hey, have you tried encouraging it? As Jason would say, you can do it, little compooper. Yeah. I have not spoken encouraging words to my computer before I try to boot it. Maybe I should try that. Okay, smoke basin. These caves seem to be lava tubes. Parts are even still volcanically active. Small hydrothermal vents. Okay. Smoke flows to the lowest point of the area it's in. For example, considering the following height map. Each number corresponds to the height of a particular location, where 9 is the highest and 0 is the lowest a location can be. Your first goal is to find the low points. The locations that are lower than any of its adjacent locations. Most locations have 4 adjacent locations. Locations on the edge do not. I'm wondering if ND array can help us here. If we can just be like, iterate over all the points and give us all the neighbors. That would be super useful. It would save us a lot of like mechanical setup work. Hey Derek, how's it going? In the above example, there are 4 low points, all highlighted 2 in the first row. Yeah. The risk level of a low point is 1 plus its height. In the above example, the risk levels are all 2, 1, 6, 6. So the sum is 15. So find all the low points. Okay. Let's go take a look at ND array and see if the array base type or array 2D or something has a function that will let us like get neighbors. I guess it would be an array or array base, right? That's where all the functions are. ND arrays definitely seems like the right thing to do here. Yeah. I just don't know what this function that we would need is called. So we got to go find it. We've got columns, we've got rows, we've got diagonal. This is probably dot product. I don't know what I is, so I'm just going to open it and check. From shape, from element, from vec, gen columns, get, index axes, indexed iter. Lanes, last, length, app. Oh, there's a mean function here. Huh. What is outer iter? Permuted axes. Range. Reborrow relative equals. Select. Split at, split complex, standard axes. Some axes. Swap axes, transpose. Use swap var view visit zeros. Okay, so returns a shared view of the array with elements as if they were embedded in cells. Cell view requires a mutable borrow of the array. So this is not what we want. This returns diagonal views. I don't think we're dealing with diagonals yet, so we definitely don't need that, right? Up, down, left, right, right. We don't need that yet. Dot, my product or matrix multiplication, also don't need that. I create an identity matrix of size n. Don't need that. Outer iter. Return an iter that traverses over the outermost dimension and yields each subview. Maybe. Permute the axis. This does not move any data. It adjusts the array's dimensions and strides. I in the jth place in the axis sequence means that self's ith axis becomes self j's axis. Oh, I'm looking at the 2D array page and can't see anything useful. Yes, because all of the functions are on the array base type. Or a lot of them are anyway. Don't think we need permuted axes. Create a one-dimensional array with start to end, so that's just range. Relative equals. Select arbitrary subviews corresponding to indices and copy them into a new array. Panics. So this might be useful. 0, 4, 3. Gives us 0, 8, 9. This is just the selection on one axis, though. Standard deviation of the axis, that's probably not what we want. The sum along axes is also not what we want. There's really no like neighbors function, is there? Yeah, presumably if you wrote the diagonal stuff, it would still be fine. But no. Windows or slices is probably my best bet. I don't think that either of those is really great, is it? Because we have to operate over like a set of rows and a set of columns. Take a look at slicing and subviews, I suppose. Methods for 2D arrays. Ooh. Ooh. Is this a new set of... rows, columns, is square. Useless. Windows are n-dimensional. Let's see, windows. Return a producer. All distinct overlapping views of size window size that fit into the array shape. This produces no elements if window size is larger than the actual array size along any axis. Produced element is an array view with exactly the dimension window size. Panx if any dimension is 0. So I think we still need to do the corners here if we do this, because we would need to do a 3x3 window. I'm going to do some light HTML and CSSing while you do part 1. Yeah, for sure. Because really what we need is a 3x3 with the corners poked out window. So if we have to do the stuff anyway, I'm not sure Windows really helps us. All right, it looks like this is going to be a second, so I'm going to see if I have any cold brew in the kitchen, but I'll be right back to keep doing the problem. Sad times, no cold brew. Yeah, that's what I concluded too. Could pad 9s around the array. Pad 9s around the array. I don't know what you mean by pad 9s. Oh, you mean like make the whole thing. Yeah, we could do that. Actually, I don't feel too bad about that, if I'm being honest. We still need to... What is it? We still need to... Like, we need to determine diagonals, I guess. So maybe we like concat it or rows and columns. It feels awkward. It feels like there should be a better solution, right? Like Windows is kind of what we want. What do you mean, do we? Because let's see, 1 here is the lowest, 5 here is the lowest. In the input, the diagonals are still included, I guess. Windows are overlapping. The windows being overlapping isn't the thing I'm talking about. The thing I'm talking about is when we get like I can't select a 3x3 here, but imagine I'm selecting the 3x3 like in the corner here. Like the 8, like the 8, the 2, the 6, and the 8 don't count for being low, right? I guess it does all go down. And you said you did diagonals and it worked. So like 3 here doesn't count because 2 is to the left of it. 2 here doesn't count because 1 is to the left of it, or to the right of it. 8 here doesn't count. I guess it's possible that there could be a diagonal that is off. Because we're looking for the one that is the lowest of all the points, right? So that one doesn't because 5 is next to it, etc. This is the one. So, but that also wouldn't count because 7 is next to it. But like there's a 4 here. And if this 7 was like, I don't know, a 9 or something, then we would think this was a low point. Yes, that's what I'm saying. That's what I was saying with the diagonals, Derek. Like, we are going to have to still pick the points anyway, even though we have the windows. And even after we do that, if we do 3x3, we don't get this top corner that has only the 4. So we would never get this 0 with windows, is my understanding. I still think putting it into an ND array is the right choice because, well, I don't know that it's the right choice anymore, but I think we can do indexed access. I'm really surprised, actually, that this is the case, that we have to window over it. Yeah. The padding fixes that. All right, let's take a look at the input and see how drastically different it is from the current input. It's probably just going to be a massive square. Yeah. So we can't rely on the size of the square. Pull this in. Put the test. We'll comment out part 2 for now. Actually, this is not even what we want. Comment this out. Drop this in test input. It still feels weird, but we'll do it. Let's do puzzle input. I guess process part 1 here is not going to be the thing anymore. It might be rectangular and not square, so watch out for that. Does it matter? If we're doing Windows, it shouldn't matter, right? Nom Rust. Car. We want to parse a single car. Oct digit is not what I want. Hex digit is not what I want. Digit 1 is not what I want. Any car. And then we parse it out. So we're going to do a separated list by new lines for any car. Not any car, but a row. And then the row will be input, string slice, I result, string slice, vac of, I guess we can go with U8s, and then let input cars equal many one any car, I think is what we're going to go with. Parse U8 unwrap. This needs to be .iter. We need these to come in, and then this is v.parse. What are we in the right day? We're not in the right day here. Carbo build. So Rust Analyzer is confused for some reason. I can't think of a good way to, I guess like we could iter and then chop iter onto the end and then put X as an iter onto the end. I think I'm just going to do the windows. And then I'll deal with the corners later. And this is dot collect. Is parse really not gonna bin part 1? Why are these tests passing? Running 0 tests. Why are we running 0 tests? We should be running 1 test, right? Puzzle input, part 1, return 0. What did I do? Running 3 tests. What directory am I in? Day 8. What directory am I in over here? I'm in day 8 again. Oh god. Did I just mess up day 8, basically? There we go. Okay, we're in day 9. We did our work in day 9. We're good. Whew. I did goof. I definitely goofed. There's a way to do car to U8, right? Some cars are out of U8's range. These won't be. Do we not have a... We have from U8. So Rust U8. I feel like I shouldn't do this, but... U8.parse. U8.parse doesn't exist. Oh wait, no, we're not in a U8. U8 parse. But we don't have a string here. No, U8 doesn't have parse. Why doesn't U8 have parse? Oh, because I have the type and not the... What is the path to a U8? Standard primitive. Is it standard primitive? I don't think primitive is the thing that I want. There's from string for U8. It's from Steratics. Function or associated item not found in U8. What am I doing? Oh, I don't have the trait for from string brought in. This plain U8. I'll check in a second after I get it to work. Can I not as string a car? There we go. That's what I wanted. And these apparently have to be U32s, so we'll be okay with that. Even though that's way too big. And we have a bunch of options here. They all have to work. So we'll just unwrap them. Okay. Called option.unwrap on a none value. Sick. New line. New line is still included. We need to not eat the new line. So I think we need take until or something like that from Nam. What does inspect do? It's basically a transparent thing that you can use to just debug. And then, So like sometimes you build up long iterator chains, right? Like map, flat map, whatever, you multiply some things, etc. Sometimes you need to stick something in the middle of that chain to be able to get a reference to whatever value you have to be able to debug it out, but not actually change the behavior of anything. That's what inspect does. It gives you the value here so that we can do whatever we want with it to print it out. And then we can continue with however we were working before. In this case, I used it to discover that we are actually iterating over the new lines. So I did any car here. And what I need to do is any singular digit. I ended up just using lines because I couldn't figure out a good way to handle this. To handle the parsing. Stopped in like 10 minutes ago, but forgot to do a typical wave. Well, thanks for hanging out, Jacob. We could do this. It's not that big of a space. Two, three, four, five, 6, 7, 8, 9, 9. I guess 10, right? And this has to be a tuple. And are we still green, red, yellow? Oops, not that. Alt does need to come in. Car is in character complete. I don't think we're going to use car, so I'm okay shadowing it. Okay, so now this only picks up exactly what we want it to. And then we want to stuff this in an ND array, right? Which means, what is it? Let's go find out. What day was that? Was that day... Let's just code the whole directory. Nope, don't want to update you right now. VS Code. Now is a bad time. Is that day 7 maybe? Well, that was a mistake. Dot dot star 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 main.rs. Well, that would work. No such file or directory. Go upper directory, get all of the directories, main.rs. Right? Oh, I guess not. I guess that's not the star.rs. So star star star. There's something different about this in new shell. I can just feel it. Okay. Ignore dir target and the array. Invalid option on command line, but it won't tell me which one. Yay. Okay, there we go. So day 4 we used it, day 3 we used it. So let's check day 4. Wow, it was that long ago. So day 4 was in a pre-built array. So we probably want to go to day 3 because I think day 3 was the from, what was it, from shapevec? I don't even have it in the current repo. Okay, well, let's go find it then. (2021), probably day 3, maybe day 4. Check the history. Day 1, part 1, from shapevec. There we go. So puzzle input, and then we have to do from shapevec. We have to get the lengths here. So we have to do output. Yeah, it's in the commit woof streaming. That was a bad day. That felt rough. Let calls equals outputs dot length. Let rows equal outputs 0 dot length. And then it's what? End row, end call. No actions available. How dare you? And we'll do outputs here. Let's go back into day 9. We'll do ND array because it seems like it's not available. So basically we'll end up with this array, which will be an array 2 or something like that. And I forget what to put inside this. This is, I don't know, U32s or something. You might need to flatten the outputs. Oh, right. I forgot about that completely. It's literally in the commit that I was just staring at too. When we map over this, I don't think we need to map over this. And then this is data. And then the return type there is board. But board had, what did board have? Board was array 2 board square. So this should be array 2 32, which should work, but is not working. Oh, it's a reference. Let's do into iters, and we'll just own it, and we'll deal with it. Could you call flat instead of flat map? I don't know. Rust, iter, flat. Let's go find out. Flatten maybe is what you were thinking of? So we can do that. It's actually literally the same thing. I will use flatten here, but we can always go back to flat map if we need to. Okay, so we get puzzle input. We have lines. Lines dot lines is such a weird name for this. We'll call this height map. Height map dot what? Windows? Is that the thing? I have so many windows open. Window size. Window size should be 3. So that should at least compile. Expected an array with a fixed size of 1 element, found one with 2 elements. Oh, it takes a tuple? That was not clear at all. Oh, so I have to do something that implements into dimension, of which just a regular number doesn't implement into dimension. That's fine. Okay, so there's that. And then I don't think we need to into iter. We can map over this. And all I'm going to do right now is probably debug v. Where's our other inspect? There we go. And then we got to collect this. And then what do we need to do with this in the end? Each number corresponds to the height. You need to find the low points. In the above example, there are 4 low points. So we need to filter map here. And then determine the risk level. Filter map point is low point, is not. Do we know? Well, I guess those are points, right? Do we need a pad or are we going to manually handle the corners? I think we're going to manually handle the corners. We could also pad. But basically, I'm pushing that problem off until later. So we do this first, and then we do that. We can't filter map on Windows. Let's see what else we have in NDArray, because NDArray has its own whole set of functions that you can call. Windows gives us Windows. Let's see what's on Windows. It implements into iter, so we could get this from an iterator or into an iterator if we want to, which we probably will because it doesn't look like there's anything really interesting here. So with that, my question is, oh, I guess ND producer is the other one. What does ND producer give us? Most ND producers are iterable, but not directly iterators. This separation is needed because the producer represents a multi-dimensional set of items. It can be split along a particular axis for parallelization, and it has no fixed correspondence to a sequence. The natural exception is the one-dimensional producers like axis iter, which implement iterator directly because it's just like iterating over a vec. Okay, so that doesn't really matter for us, I don't think. We're not going to parallelize anything today. I don't think we have enough stuff to actually even make that useful. So we'll just into iter and call it a day. Cannot infer type parameter B declared on the associative function filter map. Okay. That's fine. Let's just do sum 0 for a second. Value of type U32 cannot be built from standard iterator item integer. What? Why? Okay, that's fine. I'm not sure why that was. Oh, you know what the problem was? I was collecting it into a U32 and not a vec of U32s. That makes sense. Okay, so this is an array base. Let's debug this out because it might be nice. We are left with 3x3 matrices. So that's nice. Do we have like the ability to just index into these? Okay, return an iterator of indexes and references to the elements of the array. Elements are visited in the logical order of the array, which is the rightmost index varying the fastest. You can .get or thing RC. So we could do point, what, 0, 1? No, 1, 0. And that should work, at least. Okay, let's see. P equals 9. For this, which is the wrong spot. So it's YX. So for 789999678, we would expect 8. But really, it doesn't matter, actually, now that I think about it. Okay, so let's do top. .10. This is not bottom. This is row column. Yeah, it's not X, Y. It's row column, which is YX. Top left, right, bottom. Okay, now we have to call this something else. Points. And let point equal points 1, 1. So the center. Then we do top, left, right, bottom, contains points, or that's not what I wanted. Dot iter, dot find v, where v is less than point. And then if, or match, we'll do match on this because we need to handle both. Sum v. Actually, this can just be our return value, can it? Because either we found a low point or we didn't. That's fun. Well, wouldn't that throw away all the low point values? What do you mean? Filter map, right? And then we basically have this thing and we get all the other points. And if we iterate over it and we find one of the points that is, oh yeah. All. Yes, you're right. I did the wrong thing here. So I will not get fancy, and we will do this. Okay, we failed at the assertion, which is where we want to fail. Debug results. 4566. That doesn't sound right. To 166 is what we really want. So what did I do wrong? Top left, bottom right. As long as all of them are greater than point, then we return some point. So if we debug points, then we can kind of figure out what's going wrong here. Actually, we need to do a little bit more before we do that. Let's do, this is going to return some point, but first it's going to be debug point. Okay, so we end up with this output. Where is 0.4 is here. So this is technically accurate. For the window that we have. So do we need to actually take into account diagonals? Let's find that in the test input. That will be 398. $949. Where's 949? Yeah, that doesn't work. That is not what we wanted. 985. The windows are definitely not right. Let's go check out the windows. Also, hello, Kevin. Nice to see you. Your window is shifted? What do you mean by shifted? So we get 398, 949, 985, right? So we have this random, like, it's not giving me what I thought it should give us. It's a weird window. Yeah, I agree. I just did that, Eric. Or do you mean in the puzzle input? 2 point. Sure, we can debug the puzzle input. I mean, that's what we're doing here, right? Like, we just debugged out basically the points for each filter map. Are you saying you think that the outputs like this are off? I feel like I doubt that's true. Two 1994 and the oops, that's not what I wanted to do. Come on, VS Code. And the test input is 21994, 210, yada yada, 98999. This is all correct. Debug the array? You mean this? Why would that be any different? I think we misused Windows, y'all. I don't think this is an input problem. Two 1999. Where's our test input that I just closed out? 21999 43210. So we're chopping this into lengths of 5 for some reason. I probably messed this up. It's probably end calls and rows. Results equals 5. Is that closer? Now it's not even. So that's only 1 5. Are the others in the corners? No, they're not. But we also don't get the bottom row here. I guess we do need to pad in the end. Because if we don't pad this, then we don't get any, like, dang. I need like a partial windows or something like that. Yeah, I guess we need to pad because we can't do partial windows. So we'll just do that. If we only needed to do it for the corners, then I would have been fine not doing it. But if we need to do it for so much more than that, then we need to do the padding. So it's awkward. Let's make these, I guess, some obscene value, like 200. Actually, you know what we should do? We should make them optional. So instead of a vec of U32s, we're going to do a vec of option U32s. And realistically, what I should do here is call it like padding and just create my own enum. Fill them with 9s because it won't matter. I could do that. So we need what here? We need a yeah, if I just fill it with 9s, that doesn't tell anybody why I'm filling it with 9s. You know? Okay, so we've got outputs. We need we need an iterator. I guess we don't need an iterator, do we? There's a repeat or something in Rust, right? I guess we could do either repeat or we could do an array. Probably can't do a variable here, can I? This is going to look super weird, but I'm going to do a sum over the unwrap. I'm leaving it as a sum over the unwrap because this is unwrapping what I believe is a result. And we don't want to get rid of anything. So we want to unwrap there. We want the panic. So maybe I do expect have succeeded. Because we can't do anything with missing values. Yes, so I could do .ok, right? Like I can do .ok here, and it turns it into a sum or a none. The problem is then we aren't handling the fact if that fails, right? We aren't handling it. So we could end up theoretically with missing digits here if for some reason the input was misaligned. So I would prefer to panic and then rewrap it in sum in this scenario specifically. Yeah, non-constant value. That's not great. So we do a vec instead. Can I not do that? Okay, we do have stuff to do down there. We haven't finished the padding yet. Type annotation is needed. That's fine. Vec option U32. And this is just horizontal padding, or we'll call it top and bottom padding. it is not vec, because what I'm doing is I'm initializing this vec with all of those none values. Okay, so we have to do front and back. So this will be like top bottom padding dot iter, and then we'll concat this flattened iter into it, and then we will add this again on the end of the iter. In the meantime, we also need to add a none on the front and the back of every column. So what's the best way to do this? Nums. So that's the actual input, and then we need I don't need Stack Overflow per se. I thought there was an iterator concat. Cloned, collect, copied, count, cycle, enumerate, filter, fold, for each, fuse, position, product, reduce, scan, sum. I guess not. You can just extend to vex. That is also true. So if we wanted to stay with vex here, I could do let mute res equals vec none, and then I could do res dot extend nums and res dot extend none, and then return res. What about fuse? I don't think fuse does what we want. If I remember fuse, it like ends the iterator basically. Creates an iterator after which, creates an iterator which ends after the first none. So not really what we want since we're putting nuns in the iterator. So yeah, fuse is a thing. Consider giving nums a type. Value of type vec u32 cannot be built from option u32. Where is that? 81. You make a valid point. Okay. So here's the question. We have an option that we need to compare to an option. Can that happen passing through to the U32 or not? let's see. So we've got like none, some 2, some 1, some 3. This is going to be harder to read. If it can, today I learned. Yeah, I am, to be perfectly honest, I am not sure exactly what's happening there. So I'm a little nervous about it. We haven't added the padding on top, Derek, no. But we are getting the same result as we were before. So partially working, I believe. We are ignoring the nuns. It's interesting to me that that works. I don't know why that works. I need to look that up later. And then we extend that. And then we extend with this, which may not be correct anymore now that I'm thinking about it. We've added none to the left and none to the right. We did add none to the left and the right, right? So it needs to be +2. If T implements partial ORed, then option T will derive its partial ORed implementation. That is very cool. It's very cool that we don't have to like deal with like unwrapping the options and then dealing with them. It's very cool that we can just say option greater than option, and it defers to the underlying like U32 implementation. Okay. So n calls here is accurate, right? I think n rows becomes inaccurate as we append to this. I've done that and never really thought about why it worked. Yeah, I mean, every once in a while it's kind of like +2. What is the problem there? Cannot infer type. Okay, so this is going to get let okay, so we were left with 4866, which is wrong. But maybe we're closer. What happened if one is none and greater than some 10? I actually don't know. It cannot compare a raw value to an option, so you would have to either wrap it or unwrap the other one. I believe the nice trick of being able to go into options is only works if we have two options. So option on the left, option on the right. Let's do, where are we? Let's run this. Open it up. I forget all of the stuff that I'm debugging at the moment. This is awkward. This is really awkward to watch, though. I wonder if we can print line this. Where's the debug? The debug is point. This is points. So let's points dot. Let's do a print line, and let's do points dot map v match v. None is going to be x, and some v is going to be v dot to string. Then we'll just collect into a string, and this is going to be our new printout. Should we make sure our padded vec looks right? Yeah, I'm updating a couple of the debugs to be a little bit more readable. Points is going to be an array of arrays, actually, now that I think about it. Although we are filter mapping here. Yeah, it's going to be an array of arrays. So this is not what we want to do yet. Doing something wrong for sure. Let's see. V is a U32 found option. So points, can we just dot map on points? I guess we can. Let's just do dot iter. Maybe we can do that and turn it into an actual iterator instead of an array base. So we're iterating over each of the points, or we can do like rows or something, I think. So points.rows.into iter map over the R. The R is like an array base or something, right? If we iterate over that, we get the interior values, which should be options. Rows will give you a 1D array of calls, right? So it's columns. It still doesn't matter because I'm still fixing type errors that exist. Match arms have incompatible types. And then the only thing we have left to do is the collect. The collect value type string cannot be built from iterator, iter map, iter on option 32s. Either way, I think it's just, and yeah, it doesn't matter. We're gonna delete this code anyway. It's throwaway code. Like it doesn't matter which way we do it. None sum iter map dot collect string. I think this is where I want a string. And then this will give us one line of stuff. Which is fine, I guess. 998, 949, 492. It's a little harder for me to read that way, though. Let's do... We'll extend it with a new line. Can we extend it with a new line? Actually, now that I think about it. Oh, expected car found string. Does that count as a car? Perfect. That's what we wanted. Now I have little three-dimensional blobs of stuff when we print this out. Ugh. This is a weird blob though, right? 109 in those positions. Can I just reuse this, actually? Think about it. One, two, three, four, five. This looks like the wrong numbers. End calls should be accurate because we're getting it from the result with the padded sides, right? The flipping back and forth of like X and Y and num calls and rows is really messing with me. Let's do that. So calls is 15, rows is 12. That doesn't sound right. Ten. So that is 12. And then 5. Why is it plus? Oh, it's this plus 2 and not n rows. I put it on the wrong one. Okay, so now we have the problem where I accidentally switched the rows here to columns. That is still not printing out well, but we'll deal with it for the second. Now we're just panicking, so I can't use columns there anymore for some reason. We're still panicking. What is the panic? What's the problem here? N calls plus 2. So 5 should be 7. And rows should be 12. No. I feel like these are the opposite. I feel like they're in the wrong spots. Is it calls rows or rows calls? I think you have n calls and n rows flipped. I flipped them a couple of times. You're gonna have to be more specific. Your labels are flipped. Do you think this is n rows and this is n calls? So number of columns is 12, number of rows is 5. That makes sense. And then is this calls and rows? Or is this supposed to be flipped? Okay, so we're getting output again. We see a padded grid now. It bugs me that this API isn't actually type safe. Like, I get it. Like, making this a type of columns and a type of rows or whatever would be probably harm the user experience for people who knew what they were doing. But I would love to see like a type alias maybe there, just to tell me which is which. Okay, we still only get 5 in our results. Nine, 8, 7, 8, 5, 6. 8, 7, 8, 5, 6, 7, 6, 7. So that is correct. And then we should have a 2, 1, 0 or a 1, 0. Right? This is 2, 1, 0. This is 1, 0, 2, 1, 9, 2, which is focused on this 1. There should be a deeper version of that. There's 1, 0, 2, 1 right here. So this should pop out 0 for us. So the question is, why is it not popping out 0 for us? Yeah, that's what I'm thinking. So if we just filter for all sums, then we get 1055. Is that the correct? That is the correct. Woof. That was a lot of code. I'm just going to comment this out in case we ever need it again. If we had a... If we like new type wrapped the ND array, we could have put that as the display trait for the thing that we are working with. And then I wouldn't have to write it in the code here. I could just stick it on the ND array or the array 2. Hey, after you finish part 1, can I ask like 1 minute of your time to test my AOC solver prototype, please? Building now. Yeah, just let me know when you have it up. And is it the day 8 or the day 9 problem that you have up, or is it all of them, or like which one should I test? So point plus 1 is what we'll return, and then we will sum, and then we'll results, right? Did I mess up horribly? Yes, I did. Are y'all familiar with map or like fmap? So what we have here is point as an option. And because it's an option, let me pull this to the left a little bit first. So we have like fmap or map. It's not a trait implementation of some kind of like fmap trait or something like that. It is just a convention. But on many containers, like options or results and things like that, you can use .map to get at the value inside of the success wrapper. So for an optional type, it'll be the value inside of sum. For a result type, it'll be the value inside of OK. So we can reach into this option type and operate on that value if it exists using .map. And if it doesn't exist, this function will never run. We can make this a usize, I don't care. Apparently we can't make that a usize, so we'll make this a U32 instead. Hopefully our number doesn't go too high on the other one. Okay, so our test is actually supposed to be 15. And we did get 15 out. So this is going to pass. And then we're going to get our puzzle input. And then we're going to send this in. Where is our inputs? Input.text. Paste. And then what? Cargo run bin part 1. That number seems very small. Huzzah, it worked. Yay, padding. Let's get rid of some of these debugs because they're super annoying. Hopefully it's not like, hey, handle all of the diagonals and whatever now. Or whatever. I don't know. Part 2 feels like it's going to be nasty today. Okay, link in Discord. Link in Discord. Find link. Click link. I trust you, so I'll just pop it up. Input area day 7. We have to choose a file. I think I can choose a file. Oh, look, we're in day 7. What a coincidence. Awesome. So 352.707 and 955.197. I think I need to go to the repo and check day 7 and see what the answers were. I think I stick them in here. 352,707, 352,707, and 955, 1969, 3. 955, 1969, 3. That's right. It works. Luckily, we happen to be in our file selector on the day 7 already. But nice job, Nikki. That's awesome. And that's doing it in Wasm in the browser. There's a singular bug flying around. Yeah, in Wasm in the browser. That's awesome. I'm going to have to look at how you did this. That's really interesting to me. I think, actually, because you've shipped this, I am actually going to do the netlify functions stuff. So that you can just curl a URL and get the response. The padding approach was really nice in the end. I thought about that this morning after iterating over every row, call, index, and taking slices. Yes, the padding suggestion was really good, Derek. I appreciate that heavily. It turned out to be really good, especially for... Got the bug. Especially for the windowing approach that we took, which actually wouldn't have worked if we didn't use the padding. Okay, now you need to find the largest basin so you know what areas are most important to avoid. A basin is all locations that eventually flow downward to a single low point. Therefore, every low point has a basin, although some basins are very small. So locations of height 9 do not count as being in any basin, and all other locations will always be part of exactly one basin. The size of a basin is the number of locations within the basin, including the low point. The example above has 4 basins. Oh, are you kidding me? Find the 3 largest basins. Really? So we can use the thing that we just did to find all the low points, right? And we can expand from those low points in top, left, right, whatever direction, until we gobble up everything. That doesn't sound fun. Can we do something else here? Can we somehow use the 9s to cut a line? Like, if we're at... Maybe it'll be easier or recursive muted, or just me? I don't think I'm muted. Everybody else is hopefully responding and hearing me. My audio is going through OBS, so... Easier with recursive functions? I don't know. I think the question wants me to start at the low points too. It makes sense to start at the low points and then expand out. So like we start at 0 and then we check left and right and bottom. And if those, and then we just go for all of the numbers that are not 9 that are next to it. But that means we have to keep the location of every point. And we also have to know when to stop. Because like theoretically, we could have a basin that like snakes through like this, goes up, and then comes back. Because I have no idea how they constructed the input. So we have to assume that they could do anything. Oh, darn it. I thought about suggesting you use that graph library so this would be easier. We got sucked into the ND array stuff. Oh, interesting. Interesting thought. The question is, how do we relate things to each other if we do a graph library? Right? If we have like 2 in position 0, 0, oh, I guess we just iterate over everything, right? As we're iterating over everything, hopefully we have an index somehow from ND array. And then when we have the index, we build out the ones that are connected to it, I guess. So if we have 2, we build 1 and 3. And then when we're in 1, we build 2. So it gets to be a bidirectional connection, but I don't think that matters. So we can just go, we can touch each one once, insert them all into the graph, and then I guess we would have multiple graphs at that point, which is the thing, right? So I think we can get indexes for 2D array. The question is, can we get subgraphs, I guess, right? A matrix graph is a graph data structure using an adjacency matrix representation. Nullable type, which denotes the edge's presence, defaults to option E. Graph is backed by a flattened 2D array. For undirected graphs, only the lower triangular matrix is stored. Ooh, wait, is this going to be a thing? Where we just convert all the nines to null? And then the flattened 2D array like holds that for us and we can just query it? It would be super nice if we don't have to actually do anything. Returns an iterator of all nodes, outgoing edges from A. So how do we insert here? Add node, add edge. Parallel edges are not allowed. No edge already exists. Return none. Update edge. Son of a biscuit. I'm interested in if we can just dump the matrix into this and if that will work. So I'm looking for something that will go like from array or something. Like if we already have an array, I want to construct this from that array and then have it construct all of the edges for us. Because we can construct the edges by iterating over. But add node, add edge, clear, edge count, edges, new. New undirected. With capacity or default. Build is a trade implementation. He performs the indexing operation. I guess that just gets some kind of value. So we're indexing into the index mute, edge references, edges, neighbors, node identifiers, node references, node count, to index, from index. Visit map, reset map, from. I think these are blankets. Yeah. What about data? So I think we still have to insert. From edges. Create a new matrix graph from an iterable of edges. Ooh, is there a from nodes? This is from edges, 0, 1. Is that... Node weights are set to default values. Edge weights may either be specified in the list or they are filled with default values. Nodes are inserted automatically to match the edges. So what if we just have nodes? Node weights are set to default values into weighted edge. So a graph has a bunch of nodes, which are the points, and the edges, which are the lines between the points. I think these are node IDs. So I think what we would have here is like 0, 0, comma, 0, 1. So I think this will work. So let's pull that in. And cargo add pet graph. I'm going to be honest, I don't even think we need to find the low points. So we do this. We go to process part 2, wherever that is in this file. Drop this in here. We are going to want to do the parsing now and not pad. So let's get rid of this. Drop this in here. We'll do puzzle input 2. And this will be row 2. And we will get rid of the padding. I think we're going to end up turning 9 into a none. Can I ask an out of context question related to Rust but not about out of code? Yes, feel free. So puzzle input 2 is all of this stuff. We don't need to do any of this now because we're not going to do ND array, right? I'm hoping to find a junior Rust developer position soon. What am I expected to know for that kind of position? I think that a lot of the junior Rust positions that are happening now are people converting from writing something else into writing Rust. So when it comes to working on Rust inside of a company, the people that I'm seeing that are juniors that are working on Rust are getting hired to do something or already are hired to do something. And their company is starting up Rust for something or other, right? Like, for example, like Apollo is writing a bunch of their stuff in Rust these days. If you were on one of their teams and you wanted to work on that stuff, that would be a way in for you. As for what you're expected to know, I feel like junior developers aren't really expected to know anything. Like, in my opinion. If you're actually junior, and like, I say actually junior because a lot of people refer to themselves as junior or like aspiring developers for way too long. If you're actually junior, then it will be their job to train you, right? Combine that with the fact that Rust is gaining a lot of adoption. So a lot of people are picking up Rust for the first time right now. And you will find that between any given company, they will have different expectations for what you know, right? So I do consulting with Rust. I'm expected to know the language inside and out, know the libraries, etc., right? That kind of stuff. But for a more junior position, you won't be expected to know all of those things. You won't be expected to know everything. And beyond that, even further, depending on the domain that you're getting into, you may be required to know bits of C or something like that, right? So if you are going into a company that's using Rust and using Rust for like serverless functions or something like that, or they're writing a CLI tool or whatnot, you can get away with like just knowing Rust, just being familiar with the language, that kind of stuff. But if you're going into a company that has like a heavy C code base or like heavy C, or they're using eBPF or they're using stuff like that, then you will be probably required to also have expertise in those areas. But when it comes to being junior, our industry is particularly bad at supporting junior developers in general. Like, sum total, industry is bad at supporting junior people. So what you'll find actually when you go to look for jobs is that this company will want one thing and that company will want something completely different. So it really depends on what company you're applying to in the end. I need more water because my throat is getting kind of scratchy. I'm going to grab some and I'll be right back. But yeah, I'm sorry that's not like a better answer for the junior developer question. Like, I feel like junior developers kind of get shafted, or like kind of get screwed in the industry in general. No matter what position you're looking for, like any given company will find either a reason to keep you or a reason to not keep you. And those reasons will often not have anything to do with your technical ability at all. It's really unfortunate, but it's the truth when it comes down to it. Like, junior developers are generally like, you're not hired as a junior developer because you know a whole bunch about stuff, right? Kind of the definition of junior. And most places suck at training juniors. Most places suck at having a process for onboarding and supporting juniors. And thus, in addition to that, most places suck at interviewing juniors in the first place. It's a rough road. What am I doing here? I'm not going to use the array 2 anymore. I think I can just return this separated list, right? I mean, I guess we could do the array 2, right? I do need to get rid of these extends with the nulls. Where's real data? Real data is there. And we don't need to positive this. We can do just data. And then we have the array 2. We'll be able to iterate over it with the indexes. So now we have heat map and heat map. Indexed iter. Dot map. What are we in now? Where you have a row? Oh, indexed iter gives us the whole thing? Perfect. Oh, that's so good. So here's a question, actually, now. We have usize, right? And we have this graph that we're going to try to build up. The node weights here are set to default values. I think we need to set the node weights to themselves. So I think we don't get away with doing this sneaky little from edges thing. I think we do for node in this, because we're not going to map over this and we're not going to from edges this. So now we've got point and value. And up here in our parser, we can match on this. And if it's 9, then we are none. And if it's anything else, then we're some. And these are our weights, basically. So now down here, we don't have to worry about 9 coming in.
Because if we have a sum value, then we do something with it. If let sum weight equals value, then we do stuff. And this stuff is going to be add node and add edge, probably. Common interview questions for C++ is ubiquitous, but for Rust, as you said, I should focus on the company itself. Yes. I think that, like, Rust isn't new per se, but the rate at which it's being adopted in the industry makes it new to a lot of companies, which means that everybody has to go figure out how to interview Rust developers, and also means that a lot of people are looking for like experienced Rust developers, of which there are very few. Well, few comparatively to the number of companies that are now looking for Rust developers, right? So there's a need for Rust developers. But all of those companies have to figure out like how to bring people in. They might have like one inside the company and not know where to find more, that kind of thing. All nodes have to exist before we add an edge. Matrix graph does not allow adding parallel duplicate edges. Maybe we update edge. So add edge will panic, but update edge will let us just keep adding edges. So I think we add all the nodes that we can. Do we have to Windows over this again? I guess we do. I think we do. I think I messed up by doing this without the windows. I do think we still have to make a modification to make 9 also something that we don't want to deal with. But I think I'm literally just going to copy paste this whole thing. And then we're going to have all of that stuff, and this is going to be puzzle input 2, and this will be row 2. And this will be that other thing. This is the row 2. That's part 1, puzzle. And then this is match 9 is also going to be none. Anything else is going to be some. Yeah, the way the industry treats junior developers really sucks. And I wish I had better advice for juniors, but I also haven't been a junior in over a decade now. So like, I haven't looked for a junior engineering job in the last decade, I guess, like 5 to 10 years. So only all of what I know is basically like from the other end and from what I'm seeing from people who are doing hiring. Okay, so here we do puzzle input, and then we do the heat map. And this does a filter, but I don't think we want to do a filter. Right? So we do this. I guess it's a height map, right? It's not a heat map. So we have 3, 3. This gives us the points. I guess points 1, 1 could be none still, right? Whereas before it was definitely not. So we do if point some p point if let some p point like I said, this isn't going to be a filter map anymore, is it? I think we're just going to iterate over everything. All of this can get deleted. This is no longer there. This is there. Okay, so we've got the windows that we had before. We don't need to start from the low point, do we? Now that I think about it. You know what the problem is here, actually? What are the iteratable, like... We only need the largest pools. I didn't look up how we're going to iterate over this, did I? Edge count, edge weight, edges directed, extend with edges. Return an iterator of all edges of A in the specified direction. I thought the matrix graph doesn't... Undirected edges, that's what we want. Undirected because we just want to see everything that's connected to it. So we'll do matrix graph, new undirected. Matrix graph is not imported. We didn't even test, so it doesn't even pull it down. Cannot invert type for type parameter n. Semi-expected. Did we pull in matrix graph? I think we did. Yeah. So we do need to type this. NE directed. NE undirected. So we need to do graph is going to be a matrix graph of nodes of type U32 and an edge of type U32. I don't know. It's weird your Rust Analyzer extension doesn't automatically pick up when you add with cargo add. Does it do that for you? The thing that I've always assumed is happening here is that cargo add happens, right? And then because I haven't downloaded that dependency to my computer yet, Rust Analyzer can't use that information to give me the types. So you're saying you do a cargo add, and then you don't have to run anything else, and Rust Analyzer will pick up the types for you? Oh, this is going to be a mute graph. If we try to add a node that doesn't exist, what happens? Thanks, Luis. Appreciate it. Add a node, return the index of the new node. So this just adds a random node. But if we add another node with the same like weight, we need to be able to control the indexes, is basically what I'm concerned about here. Or we can just track this ourselves, which feels weird, but would also work. Can confirm, just added pet graph and it let me auto import matrix graph without needing to run cargo build test. Very interesting. Mine has not and does not do that. I wonder if I need to update. Index type IX that sets the maximum size for the graph. The graph is backed by a flattened 2D array. We already have a 2D array. I noticed that Rust Analyzer runs what I assume is cargo check whenever it detects a cargo to TOML. Wonder if that's what's happening. You think it's auto running cargo check and that downloads the dependencies? And maybe I'm not running the cargo check? So when we add a node here, we don't have any control over the index. Maybe you have some of that disabled in your instance. Yeah, I think I will see if there's an update for the extension and then do all of that off stream. So we can add nodes here, but we can't add nodes within a specific index. Which is interesting. So we have to track whether we inserted this or not before, I guess. It's not a huge problem. But I don't think we need matrix graph or anything special because it doesn't help us at all. So graph map. This one looks like it might have that. Add node n to the graph. Returns the n. Okay, so possibly this is what we want. Add edge. And we can add edge, hopefully from node to node. So I think this is what we do instead. We use graph map. So where's graph map? This is going to be we didn't import this. What are the types here? Any tie, node edge, and N for nodes and E for edges. Edge type tie that determines whether the graph directions are directed or undirected. So we're going to do a graph map of what I'm going to call node. So that's not going to be confusing at all. Unit, because I don't think we need anything on the edge. And undirected. And this is going to be struct node, which will just have like the value at the point, right? Actually, now that I think about it, node point is going to be a U32 tuple, and weight, which is going to be a U32. I think we can derive hash. I think for hash to be a thing, we also need like ord and partial ord and stuff like that. So hash ord, partial ord, eq, partial eq. And then we still need copy, which will also need clone. I'm not going to worry about allocations at the moment. So we have a new graph where we can insert nodes with their weights. They are hashable, so when we insert the same node, we'll get the same output. So here we have if let some weight. Actually, we don't have the indexes here, do we? This is going to be interesting. So we have windows. Windows gives us the value, right? The question is, if we do an indexed iter on this, then what we get is probably because your VS Code instance is much cleaner than most run, I think. Yes, for sure. I definitely, if I could get this in the top right corner to be removable without doing the developer tools, I would love that. I have a little script just saved there, just so I can remove that. Okay, so Windows, but we need Windows with the index. Elemental P, Windows, so we don't have that. Can we not use Windows? If we can't use Windows, it's going to be harder to get the indexes, right? I guess it won't be. If we do height map dot indexed iter, I think is the thing. That will give us the point and the value, which we can then go back into height map and find. Since we're only reading it, it shouldn't be a problem. It'll be weird a little bit. Right, because we basically have to do all of this. And then can we just collapse this comment for a second? There we go. If let sum I equals point, right? Because this is going to be point now. Then why is that a problem? Oh, right, because point is not the thing, value. I'm going to call this like maybe value, just because I want to recall this value. So if let some value equals maybe value, then we operate on it. In this case, we do graph dot add node point weight value. See you, Kevin. Fine, these can be U sizes. Expected U size found U32. And then that's unit. Okay, so we can add these nodes in, right? And then the other thing that we need to do is if I add this node and it already exists, what happens? Adds node end to the graph. Thank you. Appreciate that. I'm starting to get hungry, which is really unfortunate. Let's just do it and see what happens. I bet you what we end up with is like two, first of all, we need to run the right test here. Then let's debug graph maybe. Of course, I derive everything else, but not debug. This looks like it could be unique. 1 1 1 2. What's the test input? So we've got two. Ooh, it's hard to read this. 2 1 4. 2 1 4 is at 1 6. This is not ordered at all. Right, because the 9s don't get in anymore. So 2 1. And then 4 3 2. 4 3 2. So this is working, it seems like. Even if we add multiple times, we don't seem to get multiple nodes. So that's exactly what we wanted. So that's perfect, because it means that what we can do here is just arbitrarily add nodes, just add nodes all over the place. We do this. These are all of our points. This is going to be, well, okay, so the problem, the other problem here, shoot. Do we do this and then we do Windows? We need the actual indexed position to do Windows. Let's see. Are we going to do the way that we didn't do it before? Height map.get point. Let's do point dot 0 and point dot 1. Do we need Windows? I mean, it would be nice, right? Because like Windows could give us all the neighbors, maybe? Is neighbors a thing? Neighbors is a thing in the graph, which is why I keep thinking of it. But we don't have Windows here. We need to get the all the connection points is what we need to do. So we need to draw edges. So that works. This is going to be super awkward. I think those are going to fail at certain points. Could use 2 ranges to make it less awkward and handle edges. What do you mean by use 2 ranges? Okay, so some of these should be none. Right? The thing I'm concerned about is getting into like 0, 0 and being like -1 for a U32. So these are none. So I don't think we actually have that problem, which is kind of nice. So then we need a function that will add the node and set up the maybe use safe subtractions. I don't think we need to, actually. Because even if it underflows and wraps around, then like we don't have any values at like 63 bajillion 542. So this is left. Here's what's flowing an issue and underflowing U8s. I don't know. Seems fine. We can do this. We can debug point. Right? Are any of these points 0? None of the points are 0. None of the points are 0 because we padded it. If you remember correctly. Right? Because we padded it and we're checking for if the value is one that we should operate on, the entire outside is all values we don't touch. So the padding saves us again here because we will only ever be at 1. We will never be at 0. Is there an easy way to flatten 2 options? Doesn't really matter, I guess. Okay, so if we have one on top, then this point node point this weight right? And this is if let some weight. Then we do this. Equals top. And weight is going to need to be cloned, which is fine. Integers are copies, so we can just deref. Graph.add node, node top, and then graph.add edge, node top, and then weight is unit, I think we set it to. So we're panicking at the assertion failed, and I think this should do what we need it to do. So we can take this, I think, and do function insert. Take a mutable reference to our graph, and it won't return anything because we don't care. It also needs height map. What is height map? An array base owned repr option 2. What do we return here? We return this. And then the point, which is going to be a U32 and a U32, or is it usize? Usize and usize? And then node is going to be a node. We pass in the reference, and if we actually need to use it, then we will clone it. So here, we should be able to insert. What are all of the things? Graph, height map, point. Graph, height map. This point. And node. And this is a mutable reference, and this is a reference, and this is a reference. And then we get to just take that out. And we get to do this over and over. Opt.flatten should flatten option T. Is yeah, but it's an option reference as well. So this 2, 3, 4, and this needs to be a -1. And this needs to be a -1. So I think that gets us everything. Right? And then... And this is the point at which we need the bottom pieces, I think. The lowest points. We need to iterate over our graph in some way. Return an iterator of all neighbors that have an edge between them and A in the specified direction. Will this get us recursively all neighbors? We can get all edges muted into graph. I feel like we have graph traversal algorithms somewhere, and I don't know where exactly they live in this package. Algorithms on those graphs. Functions, condense, connected components. Return the number of connected components of the graph. Has path connecting from and to, is cyclic, strongly, minimum spanning tree of a graph. Nodes? What do you mean, get all the nodes? So this has A, B, C, D, and E, F, G, H. Connected components, graph. 2. So that'll give us the number of graphs, interestingly. Let's just do that for a second. Let's get rid of this. Is that not how it was supposed to be used? I'm gonna pull this all the way up and go back down. And then we are going to debug this for kicks. This is just like for fun, basically. I don't think we actually need this number, nor do we need 5. Okay, so that would mean that the test input has 5 basins, right? Let's see if that's correct. 1, 2, 3, 4. That is not correct. The example above has 4 basins. So this has 4 basins. But for some reason, we didn't connect some of them. Okay, so there is something here that is also interesting for us, and it was the fact that these can output digraph models. I don't know what this gets us. I don't know if we need to write this out to a file or something. It looks like we do. So let's do, can we print line this? There's got to be an online .graph or .viz like thing, right? Node keeping on before now with the default formatter. Yeah. So let's do fs write Rust write file. I feel like I don't write files that often. There's a whole bunch of like lower level stuff that we can do, like the write trait, but I don't really want anything complicated. And this will be let dot equals this, I guess. And then we will, these are going to unwrap because they are not allowed to fail. Format the debug version of dot unwrap. Write all takes bytes though, so oh, we actually do need to bring in the trait. We have dot dot text. So this is our giant graph. New shell doesn't have a dot viz, does it? That would be really cool. It doesn't look like it. That would be really cool though. Let's move dot text to dot and just give it a quick whirl. Okay. Doesn't work. Online dot viz graph is online. So we're going to take this, we're going to clip it, and I'm going to drop it in right here, and hopefully it's an SVG. Okay. Who's ready to read this? It looks like the 0.11 is the disconnected point. 1, 2, 3, 4. What? Nope. Let's see. 1, 2, and then 3 is right here. It's a little hard to see that it's actually disconnected, but it's right there. And then this is the big one. So let's take a look at the Why do they all have cyclical edges? Probably because I don't know. I don't have an answer for that. I don't know that it matters for us either. The first thing I want to do is 213 113. That's interesting. 1719 and 210. 17, right? 1 0 1 2 3 4 5 6 7. That looks like a 9. That shouldn't be in there. Did I mess up our... I messed something up. Top left basin size 3. 1, 2, 3. Should be... We're padded, so take off 1. Yes. So 0, 6, 0, 8, and 1, 9. But that still doesn't match. Right? 0, 0, 1, 2, 3, 4, 5, 6 is 3. Which should be connected to 4 and 2. But is not. See, so there's 0.01 that has 1. There's 0.10 that has 3. And there's 0.23 that has 8. Why are these two connected? Right? Why is 1, 2 connected to 2, 1? Right? 0, 1, 2 connected to 0, 1, 2, 1. So these two actually should be connected. Interestingly. Are we including diagonal somehow? I think we're including 9s somehow is the thing. So let's go back and look at our inserts. If we have a value, right? Then we create a node for that value. We did pull out the 9s earlier, as long as we are using the right puzzle input here. Puzzle input 2. Puzzle input 2 does all of this stuff for us. And then the numbers, the actual numbers that we're parsing, if we have a 9, we return none. And if we have an I, we have a 7. So we have no 9s. So we're not actually inserting any of the 9s themselves. If we have a node here, we try to do an insert for the node that is the current node plus 1 in the Y direction, right? So we try to get that node. If that node has a weight, which means that it is both not a 9, not a padding item, and also was an existing point. Oh, you know what we did? I didn't change this. Oh, that's it. That's it. That's it right there. Now we have 4. I just forgot to change the thing when I abstracted the function. So we were passing in the top point for every point is what was happening. So now if I drop the .viz in here, we see a very different thing. It's really hard to read, so, but this is the top left basin, right? We've got 0, 0, 1, 1, and 1, 0, and that's 1, 2, 3, which is exactly what we expect for the top left basin. 2, 1, 3. No more loops on itself? No, they still loop on themselves. I don't know why they loop on themselves, but I don't know that that matters. If I cared about the digraph output, I think I would look at the actual file here. So we've got labels with nodes, and do they ever point to themselves? It doesn't look like it. That's the old graph. That wasn't... This is the old graph, yes. Ah, yes, no more Thanks, Jacob. Appreciate that. Okay, so I mean, it looks right to me. Or thanks, Derek, for pointing that out. So all this looks good. What do we do with it now? Where are we in this? It's been so long today. We have the 4. We now need to iterate over each of the 4 somehow. That's our goal. Our goal is to iterate over each of the 4. If we can do that, then we've won. I keep running out of water. Okay, but why do we only get basins for local minima? What do you mean basins for local minima? Do you mean how do we get? Also, we just need the connected components piece now, right? No, we don't need either of those things, actually. We need to iterate over all of the connected components, that is. These are all very complicated graph algorithms, like A star. Maybe condensation. Condense every strongly connected component into a single node and return the result. So let's add a bunch of nodes. Those are connected. So there are cycles. I don't think we have any cycles. We don't have direction either. So that could be a problem. I can't even find the tab that I was on. Condensation. There we go. So if we do this, what do we get? Let's do that, do this, pull this in. This probably needs to be a reference or something. Or it just doesn't work for this, maybe? Okay, there we go. Cargo test. Expected graph, found graph map. I know we can do like a graph into a graph, or a graph map into a graph. I don't remember what the function is, into graph. Can't infer type. So let's say node edge undirected U32. I don't know. And then we debug the condensed graph. And this gives us node weights. Node count 4. So that gives us what we need. I guess, why do we get each local minima as a separate connected component? Because it seems reasonable to have 2 local minima not isolated from each other by 9s. Are you asking about like why they set the problem up with? We aren't doing any local minima stuff, Derek. Like at all. So I'm not sure where your question is coming from, which makes it hard for me to answer it. Don't the basins require local minimas? They do have one, but they don't require one. That's a problem setup question, right? Like, they're all circled by 9s completely, let's say. So we're basically just doing group, 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 group. If they're connected, they are part of a basin. There is additional information in the question that specifies specifically there is a minima here and there and like one for each basin, right? But for us, we don't care, right? Nodes isn't a thing. What is a condensed graph? And where can I find the iterable stuff? What does it give me? It gives me a graph. Can I just iterate over the nodes? I thought nodes was going to be a thing here. We get edges. Why do we get edges? But not nodes. Let's see. Is there a field on this that I could just access? Node count, edge count, edges. node weights. Maybe this? Maybe there's a weights or something? Node weight. Access the weight for node A. Node weights. Return an iterator. It's that's weird, but okay. Value borrowed here after move. Great. And then we get basically an array of all the nodes, right? Yeah, this is just a vec of nodes. So we do Bayesian dot iter dot map node dot weight dot sum. So we do condensed graph dot node weights dot map Bayesian oh wait, I get my confusion. The only way to stop a Bayesian is a 9 or a local minima. Every number that's not a local minima will have somewhere to flow down to. No. Like, the local minima doesn't have an impact on the size of the basin, right? So, like, there could be 2 drops, theoretically, in these basins. I think because of the way the problem is set up, they all tend to flow into 1. So, like, for example, this is 3 away from 0, and this is 3 away from 1, and this is 1, 2, 3. I don't know, but it's like because of the way the problem is set up, it flows in like that. But that wasn't a priori thing that we needed to care about. Like it wasn't a we don't need to care about the minima at all. Oh, this is a function, that's why. Cannot infer type for parameter B. What is parameter B? Oh, right. Expected use size, found map. This actually, can this be a use size? We have to do 9 times 14 times 9. So we need to get the largest 3 of them. Sums here. I'm going to collect into a vec of youth sizes, U32s, U sizes, I don't know. And then call this expected U size found unit. Yes, this is still like 0 or whatever. We'll call this U32. Okay, so we get the sums. If we debug the sums, we get a list of the basins and their sizes. So this should give us 4 of them. Wait, actually, that's the wrong thing. Number of locations, not the weights. 91493, and then Rust iterator. Is there a way to find the top three? I guess max by key, min by key, sort. We could sort and then do it. Vec, sort, Rust. Yes, that is reading this as each basin should only have one low point, compared to each basin will only have one low point. I don't think it will only have one low point necessarily, but for the purposes of this problem, it didn't matter, right? For the part 2, because we're only doing groups of stuff. Is this going to be low to high? Yes, it's going to be low to high. Don't love that. Let's do this. Sort dot iter dot reverse. Why did I call this sort sums? Dot reverse iter. Right, so that's mutating again. And then let finals finals equals sums.iter. And we'll do finals.next.unwrap times donk donk. And of course, these are all going to be an issue, as it were. Can we not multiply U sizes? Is that what's going to happen here? Or are we going to do this thing? Basically, we have why did I do this on one line? Why did I do that to myself? I don't know why I did that to myself. Okay, so in the test, when we do the multiplication, we're supposed to get 1134, which is what we get. So I'm going to put that into the test because now it passes. And then we're going to cargo run part 2. Why are we borrowing and dereferencing? Because Chris was lazy. That was the right answer for part 2, by the way. So we are good. We have beaten every day as it comes. So why are we borrowing and dereferencing? Because if we don't do this, it still works. And Chris was just being, I guess I was reading the wrong error or something. I don't know. We don't need it. I bet you because I didn't have the mute on finals, I was seeing stuff that wasn't actually relevant. I also didn't have these unwraps when I started, so like we don't need them is the end answer. But that's everything. Let's do I think we can do bench quickly. This is like, I feel like all of this code is really awkward because I don't know pet graph well and I don't know ND array well. So we're constructing an ND array and then we're constructing a pet graph. The pet graph copies all of the data all over the place. Yes, it's only a bunch of like simple structs and stuff. Sometimes you do have to do, and it's the other way around. It's a reference and then a dereference. Sometimes you do have to do that because stuff will have conversions through the deref trait and things like that. But typically when you're doing that, it's a mistake. So these run in 500 nanoseconds and 8 milliseconds respectively. Let me just chunk these out and we'll throw them in the README before, everything else. Why is that such a long single line? Okay, there we go. Criterion. I probably am not going to do any, like, I guess interesting might be the right word. I'm not going to do any optimization stuff. I feel like for the ones that run longer, sometimes I play with them off stream, but I don't think that going through this is going to be super useful. Specifically because really all we're doing is throwing a bunch of stuff into ND array and then throwing a bunch of stuff into pet graph and then iterating over it. So I don't know how useful trying to reduce allocations or improve performance is here. We're already running in 500 nanoseconds, so like it's not like we have seconds to shave off or something. What's the data out? I'm going to it right now. Delete, readme, no, not readme, cargo. Cargo plus nightly. I still haven't updated Rust and cargo. So we still have to do nightly for this. Yay. So for part 2, it was that. Why did I do part 2 first? I don't know. For part 1, it is almost a megabyte. So it's fairly large. And the part 2 was up here. It's almost 7 megabytes. This is a lot. It's a lot of space. I may take a look at this off stream and see what it's like. We just ran number 1, right? So let's go to the DAT viewer. Dat heap.json. Okay, so It runs in 600 nanoseconds. Let's see, 14,000 bytes. Is this the right one? Did I just click the wrong one? This feels like it was day 7. Yeah. Wrong day. Yes, definitely wrong day. So we're fairly large here. At what, like a megabyte almost? Yeah. So like a megabyte, which means that we don't get any of the things that are less than 10 blocks. Historically, through the advent of code this year, we've been seeing things that are smaller than that. So the puzzle input here, vec internested, gives us 80K, which feels really large. Maybe I'm doing something, maybe I can do something differently here. Iterator collect, fn mute on the parser with capacity. Yeah, this is just the puzzle input function, basically. Returning, what do we return? We return ND arrays here, yeah. So that comes out to 80K bytes, which is fairly large, I feel like. I feel like we shouldn't need that much for this. The other thing here is that I guess puzzle input separated list 1 results in 240 bytes? 240 kilobytes? These seem really large. And it's specifically in the row. What am I doing in row that's so bad? Many one alt. I wonder if many one just keeps growing that. 2-digit. We do a vec, we extend, we extend. So we're doing a couple of vecs here. Back of option, the U32s. The U32s probably need to be smaller. Because I think that they're all single digit, right? So these should be U8s, first of all. That'll buy us some space. I'm curious as to the difference between many one and some other approach. We do create this vec every single time. But if what we did with nom was actually look for the new line, I guess, ahead of time, then we could get the length of this ahead of time and do this in an array instead of doing it in a vec. So we could reduce the allocations here by pre-allocating an array of the right size with the none values. I did that on one of the other days too. My voice is getting really raspy because I don't have water, so we're going to finish up here. And then puzzle input does a separated list for the new lines in the row. That allocates another vec. We do another vec creation and collection and allocation in the puzzle input here. I bet you we have the sizes of these things. If we have the sizes when we're doing the rows, then we probably don't have the sizes of the vertical, but we do have the sizes of the vertical here at this point afterwards. So we could probably do that a little better. Let's see what petgraph is doing. It doesn't look like petgraph is really doing anything. Like there's no petgraph in this threshold. So it's possible that petgraph is doing things really efficiently and we're hiding it all via really bad parsing. A really bad allocation in our parser. Because it looks like all of this is basically the file, I guess. Is this part 1 or part 2? This is part 1. Oh, there's no pet graph in part 1. You're right. You right. Let's do part 2 and just take a look. So part 1 looks like the problem is mostly the parser. So we do the windows here and whatnot, but those are all views into things. So we don't really allocate in the actual part 1 function. And then we can look at 2 instead. Is this 2? Did I mess up? That heap.json. And this, here's petgraph stuff. So petgraph is responsible for, this is just the add edge function, which is almost a megabyte. I wonder if we can, I wonder if when we do the parsing, if we can construct this data structure that we need for petgraph earlier, and then just use references from petgraph to those things. And then maybe we only have to pay the cost of like an arc or something instead of paying the cost of copying all the numbers. But yeah, so that's that. That's going to be it for the stream for today. I will get this code up on GitHub now. Day 9. Push. So if y'all are interested in seeing day 9, it's up there now. There's the ND array stuff. There's the petgraph stuff. I assume that we'll use petgraph again. It would be nice to be a little bit more familiar with ND array and a little bit more familiar with petgraph as well. I feel like in advent of code, they come in handy. So we'll see. But that's it for the stream for today. Thanks for hanging out. Same time tomorrow as usual.